let us have another phenomenon where the electronic and the steric effects, different electronic effect, that to inductive, resonance, mesomeric effect all together, and in addition with the steric effect also influencing certain reactivity order, like the carbonyl compounds undergo one characteristic reaction called nucleophilic addition reaction. And if different carbonyl compounds are taken, we can by going through the features of this inductive mesomeric effect, we can guess in fact. Otherwise, the observed order may be in a justified manner we can explain. What exactly the nucleophilic order means? For example, if you take any carbonyl compound, we are treating with a reagent like a HCN, for example, in which H is the electrophile, cyanide minus is the nucleophile, and this compound oftenly opens up into the minus and the plus. So, there will be always delta plus and delta minus, which results in the by opening a full plus and a full minus also may be available in fact. So, the compound sometimes has a delta plus delta minus, or sometimes will be full plus full minus also available. This is not resonance, this is just opening pi 1, we do not call resonance. This is a polarized structure, this is a unpolarized structure. So, under these conditions, if you add HCN to add, no doubt H and Cn is adding accordingly, the minus is attacks on the plus, plus attacks on the minus. But the wonderful one point is, out of these two which attacks, it is not correct to say out of these two which is a stronger one, therefore which attacks, but that is not the question. Out of the C plus and O minus, C plus has only 6 electron system, see here 6 electron system. So, therefore, it is more reactive when compared with a oxygen 8 electron system. So, if surrounded electrons if you count, oxygen is fulfill the octet system, whereas carbon is having deficiency, therefore, it is more reactive. Another point also you can claim, both are electronegative. In the second point is the electronegative element with a positive charge here, that is electronegative element with negative charge. So, electronegative elements always happy if they become negative charged, but electronegative both are carbon, oxygen electronegative, maybe little more, but carbon is also considerably electronegative element which has become a positive, means it is against its wish. Therefore, these 2 points confirms that C plus is more reactive. C plus is more reactive. That is why it participate in the step 1. Let us say this is the mechanism 1. In the step 1, first cyanide minus is going to attack. So, though we add H plus cyanide minus at a time, but the cyanide minus is attacking not because of the cyanide minus is a stronger nucleophile, but because of the less stability or the more reactivity of the C plus, and the cyanide attacks here and makes a reaction. And what about the O minus? So, this is going to participate in the second step. This is in the second step that H plus will attack here. Finally, the reaction completes, O will become OH, a cyanide is added, the corresponding name you have to say, and then say it is a cyanohydrin. If the compound I have taken is acetone, for example, then you say acetone cyanohydrin. If you say it is propanone, say propanone cyanohydrin. So, the cyanide and the H added, O results in the formation of finally OH. So, therefore, we call cyanohydrin means water added type compound. So, therefore, the products are called cyanohydrin. This reaction is one of the simplest and the characteristic reaction of the carbonyl compounds, in which what is happening, though we add a electrophile nucleophile together, first nucleophile we are adding. Therefore, it is called nucleophilic addition reaction. So, the type of reaction, it is nucleophilic addition reaction. When this reaction will become easy? Whenever the plus is more, the cyanide minus attacks readily. If the plus, we have a group, for example, here there is a group which will make the positive charge less, then the reaction will become less, which makes the more positive charge, cyanide also attacks more easily, then the reaction will become more. So, therefore, depending upon the group, the reactivity of the carbonyl compound towards HCN or nucleophilic addition reaction will become fast or easy, isn't it? So, therefore, how this reaction is going to influence the mechanism oriented, once again I will tell. The group attached to this carbocation is not intermediate, it is the starting material. Starting material, if it is stabilized by this group, by taking, that is neutralizing the positive charge, nullifying through inductive effect or mesomeric effect, which cancels the sum of the positive charge, then the rate of reaction is going to decrease, right. So, therefore, obviously the reaction mechanism, if you see, then we can say the nucleophile when attacks means whenever the positive charge is more, then the reaction will become more, isn't it. So, toward this particular characteristic reaction, all said example, that is some popular compounds are arranged in the order, that order goes like this. So, toward the nucleophilic addition reaction, the first member, that is no groups at all, isn't it. Such a group is a compound is called formaldehyde, is more reactive than if one methyl is there. This is called acetaldehyde when compared with a benzaldehyde. Okay. Formaldehyde, acetaldehyde, benzaldehyde, that means all aldehydes are coming first. Over the set of ketones, in the ketones let us have a one methyl and another also methyl, two methyls containing dimethyl ketone or acetone. Then comes the one phenyl and one methyl containing ketone. Then comes both phenyls. So, at the end we have a two phenyls containing. So, let us call these compounds as a formaldehyde. Let us call this as a formaldehyde. I am abbreviating with FA, formaldehyde, acetaldehyde, right? Benzaldehyde. These are all aldehydes. Formaldehyde, acetaldehyde, benzaldehyde. Let us call this acetone, AO. This is a acetophenone, benzophenone. This part is benzo, another phenyl, benzo. This is aceto with phenyl, acetophenone, benzophenone. So, there are three ketones and three aldehydes. So, you can generalize that all aldehydes are more reactive than ketones. Now, let us see what exactly the difference here and different phenomena, how they are influencing means the most simple application factor is steric hindrance. The steric hindrance, though it is a very small issue, but in this particular example, many books are saying this is the dominating phenomena over all other features in fact. That means knowing only the steric hindrance, you can arrange all the compounds. What is this factor? So, let us take one small compound. We have a ketone whose sizes of these alkyl groups are big enough so that they are already touching. What was the angle between the two alkyls here? It is 120 degrees because sp2 carbon, isn't it? sp2 carbon will have a 120 degrees. That means this 120 degrees is exhausted because of the size of the alkyl groups. Now, let us add the same HCN is added. As I said, cyanide adds on the carbon, H adds on the O, and the alkyls remains as it is. But what is the angle between R and R? Because this carbon is sp3 carbon now, the angle becomes 109 degrees 28 minutes. That means the 120 has become decreased, the angle reduced, isn't it? Around 11 degrees decreased. That means the alkyl group starts overlapping each other. Because of the angle reduced, the overlapping will start, and which is not allowed in fact, because they occupy some space. So, the alkyl groups are not allowed to overlap. So, the reaction says no for the reaction. So, when the reaction says no, whenever the alkyl groups overlapping is more no will be there, isn't it? So, that means as the size of the R increases, the rate of reaction decreases. This is the statement you can derive. If the R's are small, the reaction is more. Let us observe in the main equation the order. So, here one side all are hydrogens, therefore, the other side whatever the big group, one side is free, that is why the rate of reaction is fast. Here two sides groups are there. So, in general you can say, therefore, one particular order you can say all aldehydes are more reactive than ketones. This is a general, you can say generally nucleophilic addition in a aldehyde is more reactive than ketone. That is a simple order you can derive. In the aldehydes also there is one alkyl group, small size. This is a phenyl, size is increased. So, as the size is increasing, rate of reaction decreasing. So, the two methyls common, but in the methyl and phenyl is there. Phenyl common, but the methyl increased to phenyl. So, as the size is increasing, the rate of reaction decreasing. Why? Because the bigger the size, overlapping will be more. So, the problem of adjustment of the groups difficult. So, therefore, rate of reaction decreasing, right. So, according to the steric hindrance, the entire that 6 compounds order can be justified, or if it is given randomly, you can immediately arrange back, seeing the size of the smaller the size first, bigger the size last, right. So, this is the alone factor also sometimes helps to define the entire order, but it is not the alone factor. We have some more factors also influencing the same order. The second simple phenomenon is plus I effect. How the plus I effect is influencing means, here the C double bond O exists as a minus sign plus, right. So, we are having a cyanide is the first attacking species to attack here. If we have an alkyl group, what happens? The alkyl group is showing the plus inductive effect. So, the charge on the carbocation will be slightly, because it is pushing the electron density, the charge is not totally goes, but it will become a dim, just like light will be there, but glowing less. That is called dim light, isn't it? Just like that, the carbocation also, the charge is spread on the carbon atom, the charge will become now less. That is the effective positive charge will be less. Therefore, the cyanide also will have a less attacking. So, the reaction takes place either slow or the percentage will be less. So, the rate of reaction, that is what we are observing, slow. So, here see formaldehyde, acetaldehyde, there is one alkyl group, right. Acetaldehyde and acetone, two alkyl groups, one alkyl, two alkyl. Therefore, based on this plus I effect, you can arrange this. Formaldehyde is more reactive than the alkyl methyl containing aldehyde, acetaldehyde, than acetone. If somebody gives this particular order, this 3 only, do not go for the phenyls, because phenyls are showing another feature, plus M effect also. No plus I effect, 1 plus I effect, 2 plus I effect. As the plus I effect increases, the positive charge decreases, cyanide attacking will become slow, therefore, rate of reaction decreasing, right. We have another feature is a plus hyperconjugation, plus hyperconjugation. How this effect comes means, whenever there is a carbocation attached with a carbon holding a minimum 1 hydrogen, this is what the hyperconjugation definition. Whenever unsaturated carbon attached to a saturated carbon holding a minimum of hydrogen, these 2 sigma electrons show conjugation with this unsaturation, that is the hyperconjugation. It results in the, let us say, this CH3 and H and H, it results in the structure C double bond C O minus, and the H will become the positive charge, right. So, this is the structure of the hyperconjugation structure of this the compound. Under this condition, if a cyanide minus want to attack, where can it attack? See, the cyanide minus cannot attack because the positive charge is not there. Sometimes it is there on the H of the plus. So, first of all, cyanide will be having a problem of attacking because there is no positive charge. Second factor, this carbon has become an olefinic carbon. On the olefinic carbon, electrophiles will attack, not the nucleophile. That is the second problem. Another problem is the plus is there on the H. So, will the nucleophile will take that H plus, means that is what happens in aldol condensation. If a base is used, base will take away the proton, becomes into water. Removal of the alpha proton or obstruction of the alpha proton is because of this phenomenon only. Because the H will become the positive, the base will take away the H plus, that is consequence reactions are alpha hydrogen reactivity in the alpha halogenation or in the aldol all other condensations through using alpha hydrogen is because of that phenomenon. So, therefore, somehow the cyanide attacking will become difficult and the rate of reaction decreases. Similar the case, another feature, fourth phenomenon is a plus mesomeric, plus M effect, mesomeric effect. This mesomeric effect also, whenever the carbocation is there, if it is attached with a benzene ring, let us say, then this benzene double bonded electrons will come here and totally the positive charge is neutralized, and the positive charge goes into the ring also. Sometimes ortho, if this is given, it goes to the para, if this is given, it goes to the ortho. So, that is why whenever carbonyl group is attached, benzene undergoes a easy nucleophilic substitution reaction rather than electrophilic substitution reaction, because the positive charge entered into the ring, a nucleophile can attack and make a substitution. So, electrophilic substitution will become tough in the ring because of this carbonyl group in fact. So, here however, we are discussing how best the cyanide will attack on the plus, means many times the plus is not there. So, therefore, attacking on this will become a tough job. So, that is why the nucleophile attacking will become less. You observe here, there is a phenyl. So, out of all the aldehydes, aromatic containing less. Out of this, one aromatic, one aliphatic less, two aromatic less. So, you can claim another factor here, isn't it? Aliphatic aromatic means aliphatic will be the smaller one than aromatic. Always aliphatic is better. In the aliphatic you find only inductive effect and hyperconjugation, but in aromatic plus M effect, I said mesomeric effect is strong and which is dominating over inductive and hyperconjugation. You too can observe the size effect, that is smaller one is always more reactive than the bigger one. So, these three individual facts are the factors. Aldehydes more reactive than ketones, aliphatic more reactive than aromatic, smaller are more reactive than the bigger. You too can show this type of the classification. All carbonyl compounds may be classified into the two types, aldehydes and ketones. So, you can say aldehydes are more reactive than ketones. Aldehydes are further divided into the two types, aliphatic and the aromatic. Aliphatic more reactive than aromatic. Aliphatic are divided into two types, smaller and bigger. The smaller are more reactive than bigger. If both are aliphatic, check the size. If one is aliphatic, one is aromatic, aromatic will be less, aliphatic more. If one is aldehyde, the other one is ketone, aldehydes are more reactive, right. Aldehyde means one side free. Whatever the side, other side, one side is free, therefore steric hindrance will not be there and decreasing. All these groups are decreasing only. Alkyl groups through plus I, hyperconjugation decreasing. Mesomeric effect aromatic decreasing only. That means whatever the group you have in the carbonyl group, it is decreases, never increases in fact. So therefore, the formaldehyde which is free from all the botherations, formaldehyde has no plus I effect, no mesomeric effect, no hyperconjugation, no steric hindrance. So therefore, without any botheration, the most reactive means formaldehyde. Formaldehyde is more reactive as the sizes and the different groups are different phenomena goes on increase, as all are decreasing factors only in fact. But in a given compound also you can take like this, for example, all are benzaldehydes only, okay. All are benzaldehyde, but one benzaldehyde is a one having no group, but another one you have a nitro group, nitro benzaldehyde, right. Another one you have a methoxy benzaldehyde, right, OCH3, paramethoxy benzaldehyde. All are aldehydes, right, all are aldehydes, all are aromatic one. So by if these groups are not there, they are identical. But how this influence on the reactivity of this one? Anyhow, the benzene shows a plasma effect, so the rate of reactivity decreases. The carbocation is nullified or decreased the positive. But what this makes means it will withdraw. So therefore, its ortho will become positive. This will withdraw the carbon where aldehyde has become positive. Therefore, what happens? If it opens into minus and plus, this plus will pull. So the positive charge will become more brighten up. So the charge on the carbon will become more. So the rate of reaction is more. That means a nitrobenzaldehyde, a nitro group increases the reactivity. Just now I said no group increases, isn't it? But here all benzenes are decreasing actually rate of react, but nitro group in benzene will increases the order of reactivity. Whereas in methoxy makes a donation, plus M effect. This is minus M effect. Originally benzene is plus M. The plus M is attached with minus M. So therefore, we are judging in fact a no group influencing group. There is a minus M group, there is a plus M group. The plus M groups makes ortho minus and the para 2 methoxy, this carbon also will become minus, this will become minus. So when there is a positive charge is there, side by there is a minus, this minus makes a double bond and the positive charge is totally neutralized. So as the plus M effect is there, benzene is in fact this itself is a plus M attached with again a plus M. So it is double acting on the carbocation of the carbonyl ring. So therefore it is neutralizing to a great extent, and therefore the rate of reactivity is totally diminished, isn't it? So the number one is nitrobenzaldehyde comes number one order, then ordinary benzaldehyde, then comes the methoxy benzaldehyde. So whenever withdrawing groups are there in benzene, order of reactivity is increasing, donating groups decreasing, isn't it? Only a methyl also, methyl shows plus I plus hyperconjugation decreases, and the nitro withdraws, nitro or aldehydes, cyanides, sulfo, all that groups withdraw, therefore rate of reaction increases, right. So this is in turn you can judge, all are common benzenes, but attached groups also you can influence and see how the rate of reaction is going to be altered. Okay. This is what where inductive effect, mesomeric effect, that is resonance and the mesomeric effect, hyperconjugation and also steric influences, all together we are applying on a one simple issue, that is the rate of reactivity, that is the only the reaction actually. Toward that reaction, all these effects if you can understand, better way you can explain, or observed features can be explained in a better way.